This is mathheals.com, where you can find more links to math and computer science YouTube videos. Let's take a look at Rolle's theorem, if I'm saying it right, and the mean value theorem. Now, Rolle's theorem says let f be continuous on the closed interval ab and differentiable on the open interval ab. If f of a is equal to f of b, then there's at least one number c in ab such that f prime of c is equal to 0. What is this saying? It's a very simple concept. If the y values are the same at two different places, this is a and this is b, then, assuming it's continuous, doesn't have any holes in it or anything like that, my graph might look like this, or it might go down and come up. But in a sense, if it crosses here and crosses here, what goes up must come down. Now, leading up to this point, my slope of the tangent line is positive. When it reaches the top up there, my tangent line becomes horizontal, and horizontal line, m is equal to 0. And that's what this is saying. If you got these y values the same, then there's at least one number such that f prime of c is equal to 0. Because again, what goes up must come down. That's a basic idea behind it. Now, these aren't used so much in day-to-day calculus problems. The two theorems we're going to look at in this section are used a lot for proofs. Let's take a look at our first problem here. And got f of x is equal to 1 over the absolute value of x minus 2 on the closed interval -4 to 8. It says explain why Rolle's theorem does not apply to the function even though there exist a and b such that f of a is equal to f of b. Well, if I plug in, this would be our a, and this would be our b. If I plug -4 in, I get -4 minus 2 is -6. An absolute value of -6 is positive 6, so this would be 1/6. If I put 8 in there, 8 minus 2 is 6. An absolute value of 6 is 6, so this is 1/6. So when I plug in a and b, the y values are the same, which is what they're indicating. But let's take a closer look at this. Let f be continuous on the closed interval ab. Well, this graph here is continuous, doesn't have any holes in it or anything. Wait a minute. No, it isn't. Sorry. Because I was thinking this would give us -2. But if I set the denominator equal to 0, that gives us x minus 2 is equal to 0, which gives us x equals 2. So this is undefined at 2. And 2 is between this. When I was looking at that, I was thinking it wasn't between that. So this is, it's not continuous here. So it's discontinuous. That's why it's, why it doesn't fit Rolle's theorem. Now, the next problem says find two x-intercepts of the function f and show that f prime of x is equal to 0 at some point between the two x-intercepts. So we've got f of x is equal to x squared plus 2x minus 15. Now, it tells us first to find the x-intercepts. Well, to find the x-intercepts, you always plug 0 into the other variable. So for finding the x-intercept, we'll plug 0 in for y. And remember, f of x is y. So we get 0 is equal to x squared plus 2x minus 15. This factors using the PSD method. Factors as x plus 5 times x minus 3 The zero factor property from college algebra, if you got 0 on one side and you factor the other side, you set each factor equal to 0. So I got x plus 5 is equal to 0, and x minus 3 is equal to 0. Which gives us x is equal to negative 5, and x is equal to 3. Okay, we just found our 2x-intercepts. And show that f prime of x is equal to 0 at some point between the 2x-intercepts. Well, this f prime of x equals 0. What that's saying is find your derivative, set it equal to 0, and solve it. So f prime of x is equal to 2x plus 2. Take your power, put it out in front, lower it by 1, and 2x just becomes 2, and negative 15 drops away. Then we set that equal to 0, and solve for x. I take 2 over, it becomes a negative 2. Divide both sides by 2, and you get x is equal to negative 1, which is between these two values. And that's what Rolle's theorem is actually indicating. They're kind of saying that indirectly. Because f of a is equal to f of b. Well, if I plug negative 5 in here, it's going to give me 0. If I plug 3 in, it'll give me 0. That's what this is telling us. So f of a is equal to f of b. This is a nice polynomial which is continuous, differentiable everywhere. Then this has at least one number such that f prime of c is equal to 0. And we found that number, negative 1. But these are our answers. I think that's the only thing they're asking. Find 2x-intercepts and show that f prime of x is equal to 0 at some point. So we did that. Let's take a look at this one. Do I have room? Yeah, probably have room. We got f of x is equal to 4x square root of x plus 2. And it says find the 2x-intercepts, so we'll start there. To find the x-intercepts, you always to find any intercepts, you always plug 0 into the other variables. So for finding the x-intercepts, we'll plug 0 in for y. And once we do that, this is already factored on the right side. And the zero factor property says you get 0 on one side and you factor the other side, you can set each factor equal to 0. So I'll set 4x equal to 0, and I'll set square root of x plus 2 equal to 0. And I can divide both sides here by 4. And we get x is equal to 0. And on this one, we got a square root. And whenever you have a square root in an equation, you want to get the square root by itself and then square both sides. So we'll take the square root of x plus 2 and square it, and 0 and square it. And that gives us x plus 2 is equal to 0. Take the 2 over, and we get negative 2. So those are our 2x-intercepts. Well, let's find our derivative. We've got 4x times x plus 2 to the 1/2. This is going to be the product rule. This will be p, and this will be q. P prime, the derivative of 4x, is 4. For q prime, here's parentheses to a power. So we'll take our power, put it out in front. What's inside the parentheses remains as is. Lower our power by 1. And then we multiply it times the derivative of what's inside the parentheses. This is the chain rule, specifically the general power rule. Well, the 1/2 minus 1 gives us negative 1/2. And derivative of x plus 2 is 1, so it drops away. So then this gives us 1 over 2 times x plus 2 to the 1/2. And our formula is p prime q plus p q prime. So plug in everything. P prime we said was 4 times q, which was x plus 2 to the 1/2, plus p, which was 4x, times q prime, which is 1 over 2 times x plus 2 to the 1/2. Well, this gives us 4 times x plus 2 to the 1/2 over 1, plus, and the 4 and the 2 will simplify. So that leaves me 2x over x plus 2 to the 1/2. Now I need to get a common denominator, which would be x plus 2 to the 1/2. Now our second fraction already has that, so we don't have to do anything there. But on our first fraction, we multiplied the bottom part by x plus 2 to the 1/2, so we have to multiply the top part by x plus 2 to the 1/2. There we go. Now x plus 2 to the 1/2 times x plus 2 to the 1/2, since they're both x plus 2, we'll add the exponents. 1/2 plus 1 gives us 1. So we got x plus 2 to the first power over x plus 2 to the 1/2 plus 2x over x plus 2 to the 1/2. Now I'm going to go ahead and merge them into a single fraction here. And I'll go ahead and multiply it through. I'll do it. 4 times x is 4x. 4 times 2 is 8. Plus 2x all over x plus 2 to the 1/2. Which gives us 6x plus 8 over x plus 2 to the 1/2. Now we want to set that equal to 0. So I got 6x plus 8 over x plus 2 to the 1/2 equal to 0. And always whenever we're solving, have it set equal to 0. We're not finding critical numbers here, so we don't need to worry about setting the top part equal to 0 and the bottom part equal to 0. We're just solving. So we're going to multiply both sides by the LCM of all our denominators. Well, we only got one denominator, so that is our LCM. So we'll multiply both sides by x plus 2 to the 1/2. Now on this side, the x plus 2 to the 1/2s cancel, and we've got 6x plus 8. And 0 times anything is 0. Always the way it works is if you're actually solving, and you got to set equal to 0, and you got a fraction, you always just set your numerator, the top part, equal to 0. Take the 8 over, it becomes a -8. Divide both sides by 6, and we got -8/6, which gives us x is equal to -4/3. Now that's -1 1/3, which is between 0 and -2, or -2 and 0. And that's the second part. They wanted to show that that this is between these two values. Let me save this. There you go. Calc 1, Rolle's theorem, and what's the second part of this? Mean value theorem. Page 01.pdf. Okay. Let's take a look at our next example. Still dealing with Rolle's theorem. Got f of x is equal to x squared minus 4x minus 32, and between -4 and 8. Our instructions say determine whether Rolle's theorem can be applied to f on the closed interval. So let's look at that first. Rolle's theorem. Let f be continuous on the closed interval. Well, this is a polynomial. This is continuous everywhere. So that's fine. Differentiable. Well, this is differentiable between -4 and 8, so we're fine. If f of a is equal to f of b, well, this is a and this is b. Let's see if they're equal. So let's first find f of a, which is f of -4. So that's going to give us -4 squared minus 4 times -4 minus 32. -4 squared is 16. -4 times -4 is a positive 16 minus 32. and that gives us 0. Now let's find f of b, which is f of 8. So that gives us 8 squared minus 4 times 8 minus 32. 6 squared, or 8 squared is 64 minus 4 times 8 is 32 minus 32. And 64 minus 32 is 0. So they're both, f of a does indeed equal f of b. So that works. So that's the part to determine whether you can do it or not. Well, let's see what else they say. If Rolle's theorem can be applied, find all values of c in the open interval, such that open interval AB, such that f prime of c is equal to 0. So what that's saying for Rolle's theorem, step 1 says find derivative. That's what the f prime indicates. So step 1, find the derivative. So we've got f prime of x is equal to 2x minus 4. Then the equals 0. That says set it equal to 0 and solve it. So step 2. Set equal to 0 and solve it. So we'll set the 2x minus 4 equal to 0, which gives us 2x is equal to 4, or divide both sides by 2, and we get x is equal to 2. Now, between negative 4 and 8, they have the same y values at the endpoints here. It means it has to turn around and come back up, or come back down, as the case may be. In this case, this is x squared, so it's opening up, which means that it here it's equal to 0, then it goes down, reaches this point at x equals 2, it turns around and comes back up. We're going to see in the next lesson that indicates a relative min, relative max for a particular problem. Let's see what else they're asking for. Okay, find values of c. This is our values of c. Okay, let's look at another one. Got f of x is equal to x squared minus 4 over x plus 5 between negative 2 and 2. Now our instructions say, hopefully I have enough room there. Yeah, I think I do. Instructions say determine whether it can be applied. Well, let's go up here. Let f be continuous on the closed interval. Well, this is a fraction. There's one place where it's discontinuous. For discontinuity, you set, when you have a fraction, you set your denominator equal to 0 and solve it. So we got x plus 5 is equal to 0, or x is equal to negative 5. This is one place where it's discontinuous. Because if I plug negative 5 in for the x, I get negative 5 plus 5, which gives me a 0 in the denominator. And you can't have that. But negative 5 is in between negative 2 and 2. So we're fine. This is continuous in this interval. Differentiable. Again, if I went through and found a derivative of this, the place where the derivative doesn't exist is also a negative 5, which we'll see in a minute. But that's okay. If f of a is equal to f of b. Again, this is a and this is b. So let's check that. F of a equals negative f of negative 2. So we'll put negative 2 in for the x. So we got negative 2 squared minus 4 over negative 2 plus 5. Now negative 2 squared is 4. 4 minus 4 gives me 0. And 0 over the 3 would give us 0. Let's find f of b now, which is f of 2. Put 2 in for the x. I got 2 squared minus 4 over 2 plus 5. Well, 2 squared is 4, and again, 4 minus 4 gives us 0. So we have 0 over the 7, which gives us 0. So f of a is equal to f of b. So that's okay. That says then we can do it. Back down to our problem. So we need to find our first derivative. Remember our two steps. So we got f of x is equal to x squared minus 4 over x plus 5. And this will be p and this will be q. P prime, the derivative of x squared minus 4 is 2x. Q prime, the derivative of x plus 5 is 1. So our formula for the quotient rule is p prime q minus p q prime over q squared. P prime we said was 2x times q, which was x plus 5, minus p, which was x squared minus 4, times q prime, which was 1, all over q squared. Okay. Up on top, I can't factor anything out they have in common, so I'll go ahead and get rid of parentheses, combine together like terms, see what happens. 2x times x is 2x squared. 2x times 5 is 10x. The negative that's out in front of this will flip the sign of everything inside the parentheses, and the 1 will drop away at the end. So this becomes a negative x squared plus 4 over x plus 5 squared. 2x squared minus x squared gives us x squared plus 10x plus 4 over x plus 5 squared. And that's our derivative. Now our second step is to set that equal to 0 and solve it. So we got x squared plus 10x plus 4 over x plus 5 squared equal to 0. And we already mentioned earlier that if you got a fraction equal to 0 and you're actually solving it, not finding critical values, critical numbers, all you do is set your numerator equal to 0. And that's what we'll do. We'll set the x squared plus 10x plus 4 equal to 0. Now this doesn't factor, so we have to use a quadratic formula. A is the number that's in front of our x squared, which is 1. B is the number that's in front of our x, which is 10. And c is our number at the end, which is 4. And our quadratic formula is negative b plus or minus square root of b squared minus 4ac all over 2a. So we have negative 10 plus or minus 10 squared minus 4 times a times c over 2 times a. So we got negative 10 plus or minus 10 squared is 100 minus 4 times 1 is 4 times 4 is 16 all over 2, which gives us negative 10 plus or minus 100 minus 16 is square root of 84, I believe, over 2. And this factors a little bit. I'm not sure how much exactly, but definitely a 4 comes out. 84 is 2 times 2 times 21. 21 is just 3 times 7, so I don't have to break that apart or anything. Over 2. Which gives us negative 10 plus or minus. Again, the square roots, we're looking for a pair of numbers. So we got a pair of 2's comes out. And we're left with 21 inside. Over 2. Now remember with the quadratic formula, if you can divide this number, and this number by the same number, do so. And they're all divisible by 2. So that gives us negative 5 plus or minus 1 square root of 21 over 1. Which gives us negative 5 plus or minus square root of 21. Now we're looking between, what are we looking between? Negative 2 and 2. So I'm going to use my calculator here and see which one falls in that range. I shouldn't have to do this, but I'm tired. It's nearly 8 o'clock, way past my bedtime. Now, negative 5 plus square root of 21 is negative 0.42, which is between these two values. So definitely, the negative 5 plus square root of 21 works out. Now let me try a minus and see what I get. Though I know it won't work, because negative 5 minus anything is beyond the range. Oh, why am I even plugging that in? Okay. So that's our only one that actually works. So that's our C value. Let me save that. There we go. And let's look at our next problem. Rolle's theorem again. We got f of x is equal to sine 2x between negative pi and pi. First, determine whether it can be applied. Okay, let f be continuous on the closed interval. Well, sine and cosine are nice and continuous, so they're just loopy-loop over and over, so that's fine. Differentiable, again, is fine. F of a is equal to f of b. Let's check that. This would be a, and this is b. So we want to find f of a, which is f of negative pi, and that gives us sine of 2 times negative pi, which gives us sine of negative 2 pi. Now remember odd functions. If you got a negative, you can put negative out in front. So that gives us negative sine 2 pi. And if we look up 2 pi on our unit circle, it starts back at the beginning there. It's 0. So negative 0 is 0. Well, let's find f of b. That's f of pi, which is sine of 2 times pi, which, since this is 0, this is also 0. So that works. They're both equal to 0. Well, then we can apply Rolle's theorem. So let's go ahead and take the derivative. Step 1. Well, the derivative of sine is cosine. But since it's more than a single x here, we have to multiply it times the derivative of what follows that. So multiply times the derivative of 2x. That's the chain rule. The derivative of 2x is 2, so this gives us 2 cosine 2x. Now step 2, we want to set that equal to 0. And so I got 2 cosine 2x is equal to 0. I can divide both sides by 2, and I get cosine of 2x is equal to 0. Different ways you can actually solve this one. You can use your trig identities to rewrite cosine 2x and do it that way if you wanted. But I'm going to do it another way. I like this other way because it kind of prepares you for when you have anything in here, not just 2x, but 3x, 9x minus 1, whatever it might be. If you have more than a single x here, you're going to look where cosine is equal to 0 in your unit circle. Where cosine is equal to 0. Well, if I look at my unit circle, here at pi over 2, this point is 0, 1. Down here at 3 pi over 2, our point is 0, negative 1. Cosine is the x part on a unit circle, so at pi over 2, it's equal to 0. At 3 pi over 2, it's equal to 0. Well, but we have more than x here, so we're going to take this 2x and we're going to set it equal to the pi over 2. We'll also set it equal to the 3 pi over 2. So I got 2x equals pi over 2. Multiply both sides by 1/2. And we'd get x is equal to pi over 4. Question is, if this is between negative pi and pi, and it is, so that answer is okay. This one, if I set 2x, again, what's inside the parentheses here, equal to the 3 pi over 2. If I multiply both sides by 1/2 again, I won't write out the step, but we get 3 pi over 4, and that's okay. That's between those. Well, there's some other places where cosine is equal to 0. If we start off with our initial pi over 2, and we add 2 pi to it. Because if I'm right here, if I add 2 pi to it, it goes all the way around the unit circle, and we're back where we started. So this is also equal to 0. Well, this is a mixed number. If I take 2 pi times 2, that gives me 4 pi, plus pi gives me 5 pi over 2. Now we're going to see something about this particular one. But again, I'm going to set the 2x in my original equation here equal to that and solve it. So we got 2x is equal to 5 pi over 2. Multiply both sides by 1/2, and we get x is equal to 5 pi over 4. Or that's equal to 1 and pi over 4. Yeah, I didn't write that right. I wanted to really show it. This is equal to 1 and 1 pi over 4. 1 and 1/4 pi. I still didn't write that right. Boy, it's, yeah, very good at bad. Okay. It's just 1 and 1/4 pi. That's what I was trying to say. And it's past pi. Because remember, we're only looking at the interval up to pi. So that, since it's past that, means we can cross that off. And it means we don't have to go any further on this. That in that direction. Okay. Now go in the other direction. We got some other places. Here at pi over 2, it's equal to 0. And if I were to go in reverse direction, let's take pi over 2 minus 2 pi. Take a look at that. Well, this is a mixed number. If I take negative 2 pi times 2, that's negative 4 pi plus pi, negative 3 pi over 2. That's also equal to 0. And if I take this one, oops, the 3 pi over 2, and we subtract 2 pi. That's going to give us negative 2 pi times 2 is negative 4 pi plus 3 pi gives me a negative pi over 2. Is also equal to 0. Just like before, we're going to set this 2x equal to each one of these. So we got 2x is equal to negative 3 pi over 2. Multiply both sides by 1/2. I won't show the steps again, but that gives us negative 3 pi over 4. And that's in our range, which is from negative pi to pi. On this one, I'll set 2x equals to negative pi over 2. Multiply both sides by 1/2, and you get x is equal to negative pi over 4. And that's also that. Now I could, instead of just subtracting 2 pi, I could subtract 4 pi. And here I could subtract 4 pi. What I'm going to find, though, is those actually go past my interval. They become less than negative pi. So those are our 4 answers. Now, very important item here is if we say this y value is the same as this at these two different points, it means a graph must come up and then come back down in order to cross over here. There's no other choice. But there's nothing saying what it's doing exactly. You might have it do a lot of different things like that. So it might do it 3 times, might do it 5 or 10. All you know for sure is that if it crossed here, went up, it's going to come back down over here. Or if it went down, it must come back up. So don't be surprised if you end up with more than one answer. That's entirely possible. Let me save this. And let's talk about the mean value theorem. Mean value theorem says if f is continuous on the closed interval AB and differentiable on the open interval AB, then there exists a number C in AB such that f prime of C is equal to f of B minus f of A over B minus A. Okay, well let's see what this is saying. We got f of x is equal to 3x squared from 0 to 1. I'm going to holler at my son to bring me a pop. I'm dying here. Hey Eric, bring me a Diet Dr. Pepper out of the refrigerator, will you please? Thank you. This is the mean value theorem. I went to the YMCA and rode the exercise bike and kind of dehydrated myself. Talking isn't helping any here. Thank you. There we go. That'll help. Okay, so mean value theorem. Step 1. We're going to find our derivative. That's what this, let me go up to our formula. That's what this says, f prime. So, f prime, if you got a extra power, again, take your power, put it out in front, lower your power by 1, which gives us 6x. Step 2, find f of b minus f of a over b minus a. That's the right-hand side of this formula. Well, our interval here, this is a and this is b. So let's first find f of b. F of b is equal to f of 1. And we put that in the original function. So we've got 3 times 1 squared. 1 squared is 1 times 3 is 3. F of a is equal to f of 0, which is equal to 3 times 0 squared. 0 squared is 0 times 3 is 0. So now f of b minus f of a over b minus a. F of b we just said was 3 minus f of a, which is 0, over b minus a. So 1 minus 0, which would give us 3. Step 3. Set the derivative equal to the value from step 2 and solve. That's what this says. Find f of b minus f of a over b minus a, find a derivative, set them equal to each other, and solve. So our derivative was 6x equals, and then the value from step 2 was 3. Now I divide both sides by 6, and 3/6 gives us 1/2. And they're saying determine whether the mean value theorem can be applied. I should have said, yeah, this is a polynomial, everything's okay. I'll do that on next problems. Find all values of c in the open interval such that that's true. So these are our values of c where that's true. Again, this doesn't have a whole lot of meaning. It's more used in proofs, the mean value theorem is, than like actually working problems in the next section. Okay, let's look at this one. We've got f of x is equal to x to the third minus 2x between 0 and 5. Okay, now determine the mean value theorem can be applied. So It's continuous and differentiable. Polynomial always is, so that's okay. So let's go through our 3 steps then. Remember, our first step was find our derivative. So f prime of x, take your power, put it out in front, lower it by 1, and negative 2x becomes a negative 2. Step 2, we want to find f of b minus f of a over b minus a. Well, this is a, and this is b. So f of b is going to equal to f of 5. Plug that up here. We get 5 to the third minus 2 times 5, which gives us 5 to the third is 125. 5 times 5 is 25, times another 5 is 125, minus 2 times 5, which is 10. That gives us, what is that, 115? Assuming I didn't make a basic math error. Now our f of a, that's going to equal to f of 0. So that's equal to 0 to the third minus 2 times 0. 0 to the third is 0. 2 times 0 is 0. So this just gives us 0. So f of b minus f of a over b minus a. F of b is 115 minus f of a, which was 0, over b minus a, so 5 minus 0. And that goes into that 23. Let's see, 5, 1, yeah, 23. Step 3. Set your derivative from step 1 equal to the value we just found. So I'll set 3x squared minus 2 equal to 23. Take negative 2 over, so we got 3x squared is equal to 23 plus 2. So we got 3x squared is equal to 25. Divide both sides by 3. And we get x squared is equal to 25 over 3. Now the square root property from college algebra. If you got something squared equal to the other side, you drop your squared, and you put a plus or minus square root around the other side. Now we don't want a fraction inside of a square root when it's all numbers. So we're going to split it up, put a square root on top, and square root on the bottom. Square root of 25 is 5 over square root of 3. Multiply the top and bottom by the square root of 3, and we get 5 square root of 3 over 3. Now, we're looking between 0 and 5, so obviously the negative isn't going to work. But let's take a look at this one. 5 square root of 3 over 3. Let me plug that in my calculator. And, actually, my son brought in my Kindle Fire, so I'm assuming it's getting low in battery, so I'm going to go ahead and plug it in. There we go. Okay, so 5 square root of 3 divided by 3 gives us 2.89. And 2.89 is between 0 and 5, which I knew it had to be because that's what the mean value theorem says. So that's our value. Let me save that. And let's look at our next problem. Number 9. We got f of x is equal to the absolute value of 5x plus 2 between negative 3 and 4. The first condition, see if you can use it. F is continuous. Well, it's continuous from negative 3 to 4, so that's fine. And differentiable on the open interval. This one, there's one place where it's not differentiable. And if I were to go through and find the derivative to demonstrate it, let me show that. We got our formula. Let me go ahead and write it down because we don't see it that much in calculus. The derivative of the absolute value of u, where u can be anything, is equal to u over the absolute value of u times u prime. So this will be u. So for our derivative, that's going to equal to u, which was 5x plus 2, over the absolute value of 5x plus 2, times the derivative of 5x plus 2, which is 5. Now, obviously, the derivative doesn't exist where the denominator is equal to 0. If I set that equal to 0, the absolute value of 5x plus 2, of course, the absolute value can drop away. So we've got 5x plus 2 is equal to 0. Take the 2 over, becomes negative. We get x is equal to negative 2/5. Negative 2/5 falls between negative 3 and 4. So it doesn't meet the criteria for being differentiable on the open interval of that. So cannot use the mean value theorem. Okay, number 10. Let's take a look at this one. Grab a drink here. Got f of x is equal to the square root of 5 plus x between negative 4 and 4. It says first determine whether the mean value theorem can be applied. Well, let's look at where this is continuous. And it kind of goes hand in hand with the derivative. Your domain, when you got a square root, radical with an even index, is you take what's underneath your radical, the 5 plus x, and you set it greater than or equal to 0. We just can't have a negative number in there. Take the 5 over, and we get x is greater than or equal to negative 5. Well, our interval is from negative 4 to 4, which is okay, because this is where it's continuous. So we're fine there. It's continuous everywhere. Differentiable. Well, when we find a derivative, it's going to end up putting the 5 plus x in some form down in our denominator, which means that the derivative doesn't exist at negative 5, which again is okay because that's not in our interval here. So we can use the mean value theorem. So our first step, let's find our derivative. Well, we want to rewrite that as 5 plus x to the 1/2 power. We never want radicals. Now here we have parentheses to a power, so we use a chain rule, specifically a general power rule. Take our power, put it out in front. So I had the 1/2 out in front. What's inside the parentheses remains as is. Lower your power by 1 times the derivative of what's inside the parentheses. So we got 1/2, 5 plus x, 1/2 minus 1 is negative 1/2. The derivative of 5 plus x is 1, so it drops away. So this gives us 1 over 2 times 5 plus x to the positive 1/2. Okay. Step 2. Remember, this is a and this is b. So we want to find f of b, which is f of 4. Plug that into our original function. So we got 5 plus 4, which gives us square root of 9, which gives us 3. We want to find f of a, which is f of negative 4, which is 5 plus negative 4, which is square root of 1, which gives us 1. So f of b minus f of a over b minus a. F of b we said was 3 minus f of a, which is 1, over b, which was 4, minus a, which is negative 4. 3 minus 1 is 2. negative negative becomes a positive, so 4 plus 4 gives us 8, which gives us 1/4. Step 3. Set your derivative equal to the value we just found, so equal to the 1/4. Now, there's different ways you can solve this. This is a proportion, so you can cross multiply. Take the 2 times 5 plus x to 1/2 times 1 and the 1 times 4 and set them equal to each other. You could also, if you ever have a single fraction equal a single fraction, you can flip both fractions. And then if I flip both fractions, I'm going to have 2 times 5 plus x to 1/2 equal to 4, because the 1's would disappear. Divide both sides by 2, so we got 5 plus x to the 1/2 equals 2. 4 divided by 2 is 2. Now here, we want to, remember this is a square root, so that's like the square root of 5 plus x is equal to 2. And this is a radical equation. With radical equations, we get the radical by itself, no numbers in front of it, no numbers after it, and then we raise both sides to the power. Well, this is a square root, so it's by default, or raise both sides to the power of the index, I should say. This is square root, so there's no number in the little slot right here, so it's by default 2, so we'll square both sides. So we got square root of 5 plus x squared is equal to 2 squared. So we got 5 plus x is equal to 4. Take the 5 over, and we get 4 minus 5, so we get x is equal to negative 1. Now if I look up here, negative 1 is between negative 4 and 4, and that would be our answer. Let me save that page. There we go. Yeah, let's look at our next problem. Number 11. We got f of x is equal to cosine x from pi over 2 to 3 pi over 2. It says first determine whether you can use it or not. Well, cosine and sine again are continuous everywhere. Nice loopity-loop graphs. Don't have any holes, don't have any discontinuities. And if I take derivative of it, it's also a loopity-loop, because the derivative of cosine is negative sine. So that's fine. So step 1, find our derivative. Derivative of cosine is negative sine. Again, remember this is a and this is b. So step 2, we want to find f of b, which is f of 3 pi over 2. And I plug that in my original function, so I got cosine of 3 pi over 2. If I look at my unit circle, down here is 3 pi over 2, which is 0, negative 1. And cosine is the x part, which is 0. F of a, that's going to equal to f of pi over 2. So we get cosine of pi over 2, which is up here, which is 0, 1. And cosine is our x part again, so this is also equal to 0. So f of b minus f of a over b minus a. We're going to get 0 minus 0 over 3 pi over 2 minus pi over 2. Which the bottom part really doesn't matter, because 0 minus 0 is 0, and 0 divided by anything is 0. Step 3, set your derivative, which was negative sine x. Set it equal to the value you just found, which was 0. And then solve this. Well, we divide both sides by negative, and we get sine x. 0 divided by negative 1 is 0. Now if I look around my unit circle where sine is equal to 0, here at 0, it's equal to it. This point here is 1, 0. And over here at pi, it's also equal to sine. Never mind. Sine, which is our y, is also equal to 0. So we get x is equal to 0, x is equal to pi. Now I could keep on going actually. Go in this direction, 2 pi, 3 pi, and so forth. Go in this other direction, we'd have negative pi. But let's see where we're looking between pi over 2 and 3 pi over 2. So from pi over 2 down here to 3 pi over 2. So this is where we're looking. Well, the only one that falls in that range is the x equals pi. So that's our answer. Let's take a look at this problem. Got f of x is equal to e to the 5x between 0 and 3. Well, when you have e to a power, it's continuous everywhere. It's just a nice graph, and the derivative of it's also continuous. It's kind of like a polynomial. You're fine everywhere. So let's go through our steps. First step, find our derivative. So for f prime, the derivative of e to a power is e to the power times the derivative of the power. That's a chain rule. Derivative of 5x is 5, so we got 5e to the 5x. Step 2, this is a, this is b, so we want to find f of b, which is f of 3, which would give us e to the 5 times 3 power, which gives us e to the 15. We want to find f of a, which is f of 0, which is e to the 5 times 0. 5 times 0 is 0, and e to the 0 is 1. And make sure I don't run out of room here. So then we've got f of b minus f of a over b minus a. So we're going to have e to the 15th power minus 1 over b minus a, so 3 minus 0, which gives us e to the 15th minus 1 over 3. Step 3, set our derivative, which was 5e to the 5x power, set it equal to this. So we got e to the 15th minus 1 over 3. Now we want to solve for x, and this is an exponential equation, and our steps for solving an exponential equation says get the power of the variable and the exponent by itself. No numbers in front of it, no numbers after it. Well, we can multiply both sides by 1/5 to get rid of that number. That's the same as dividing both sides by 5. But if there's already a fraction over here, you're probably going to find it easier to multiply both sides by 1/5. Well, those disappear, and we got e to the 5x equals e to the 15th minus 1. 5 times 3 gives us 15. Now our next step in solving an exponential equation is to take natural log of both sides. So we got natural log of e to the 5x is equal to natural log of e to the 15th minus 1 over 15. Now remember, when you got natural log and e, they cancel each other out. So we got 5x is equal to natural log of e to the 15th minus 1 over 15. Multiply both sides by 1/5 again. And e to the 15th minus 1 over 15. Those cancel, and we got x is equal to that. The assumption is that that's between those two values, whatever those values were. What values did we have? 0 and 3. Let me plug in my calculator just to make sure. So I got 1/5 divided by 5, natural log of e to the 15th, e to the 15th minus 1 divided by 15. 2.46, which is between those. Had to be. That's what the mean value theorem says. So as bizarre as that one looks, that is our answer. So let me save that. I think that was our last problem. Yeah, it was. So let me stop the recorders.